I study these animals because they're intrinsically fascinating. I am interested in how nature works. And we have nature all around us, but we don't pay much attention to it, but we're part of it. My intent here is to learn how one animal group works, but I'm interested in unraveling some of the bigger principles of something we all know about, and that's visual camouflage. So we have some bigger animals down here.
This is Carl Zimmer for the New York Times. In his laboratory in Woods Hole, Massachusetts, Dr. Hanlon studies cuttlefish, a group of animals related to octopus and squid.
Sometimes they'll go for my finger. Watch him attack my finger. Whap! He went to grab me right there.
Cuttlefish are masters of camouflage, and scientists know very little about how they disguise themselves so well. Dr. Hanlon is running a series of experiments to find out.
So what we have here is we've got the animal right down here in a small round chamber, and we have a camera placed here, and we can remotely control the camera so that we can zoom in on the animal and get the image we want.
In this experiment, he wants to see how a cuttlefish changes its skin patterns when its eyes see different things.
The left eye gets certain visual input, the right eye gets different visual input. And the question we pose is, when the animal gets conflicting information about what camouflage pattern to turn on, which one does it choose? It's showing a little bit of a hybrid pattern, which is quite unusual to us. So maybe it is that they don't just turn one or the other on, maybe they will blend their patterns sometimes.
Dr. Hanlon's experiments with cuttlefish have led him to a theory for how they are able to so perfectly and quickly blend into their surroundings.
These animals don't have 10 or 20 camouflage patterns. When we study them carefully, we found, counterintuitively, that they only seem to have 3 basic camouflage pattern templates, I'll call them. They're uniform, mottled, and disruptive. And in the laboratory, we can test each of these pattern types, and that the animal's magic is looking at a complex visual scene and only picking out 1 or 2 visual cues to turn on the right camouflage pattern type.
Dr. Hanlon believes that all animals that disguise themselves use the same 3 categories. For all the variety of camouflage, there may be a limited number of ways to fool the eye.
That would tell us, or at least suggest to us, that all these animal visual systems, animals that can see far more and far better than we can, are being deceived perhaps just by 3 basic tricks. That's a big question that interests me. I'm not going to be able to answer it in my lifetime, but at least provides a framework to test this complicated issue of animal camouflage.
Inspiration for lab experiments comes from watching cuttlefish and their relatives in the field.
I think field work is key to everything. I'm a diving biologist. I think I've made somewhere between 5,000 and 6,000 scientific dives in my career. Getting into the natural environment where the animals have to evade predation under changing light conditions day and night is really critical to understanding what we call the behavioral ecology of these animals. We're talking about visual predator-prey interactions. You cannot reenact those situations in a laboratory very well.
But you can take those situations back with you, thanks to powerful, cheap, high-definition video technology.
You've got all this bright white sitting there. Watch the arms go white here in a minute. Now they're kind of somewhat camouflaged, and now the animal is backing into this algae, so the eyes are surveying this now. Now the animal is taking on the texture and the color. If you back off, you really can't even see the animal. It's just beautiful camouflage. Digital photography and digital video have revolutionized our study of animal behavior, in this case underwater. And the reason is that we can take, for example, a high-definition video camera that we're using now, and each of the 30 frames per second is a 2-megapixel still image. That's gold to me because we do image analysis on each image, and there are enough pixels to give us the resolution we need.
Dr. Hanlon will follow a single animal for hours, a recipe for serious tedium. But every once in a while, he captures a remarkable moment.
I was following one individual octopus for almost an hour. I saw it in the distance and approached it very, very slowly. And I just came in closer and closer at slow speed until the front of the camera was practically touching the octopus. And at that moment, it showed me the full repertoire of what it does. And it was like slow motion. It went from camouflage to bright white to scare me, ink on my face, swim off.
The video ended up on YouTube, where it has been viewed over 1 million times, many viewers still don't believe it's real.
To me, it's very gratifying. That fulfills my artistic side and my scientific side as well.
Diving the world's oceans may sound romantic, but it's not without its dangers.
Most dangerous animal I've ever dived with is the Humboldt squid. They are approximately the size of me, 100 to 160 pounds. And they are the ultimate predator. I have dived with them in the Gulf of California. The very first time we leaped in the water at midnight in a pool of light behind the boat when there was a Humboldt squid right at the surface, before our bubbles cleared, one of the animals rushed my partner, Ryan Scarry, and grabbed his $30,000 camera, and they were in a tug of war. He was screaming. I don't know what the squid was saying, but eventually the squid let go. That was my very first 30 seconds with a Humboldt squid.
In spite of the tedium and the occasional squid attack, Dr. Hanlon has remained a devoted fan of his animals for 30 years.
I think in the end, I'm interested in discovering things, and I think most of my colleagues in biology are trying to discover how the natural world works. That's what biology is all about.